So continuing on with the descriptive stuff about chemistry, not the numbers yet, that's coming up, but one of the things about matter is we use properties to describe matter. And this is, again, this is like, oh, that makes sense, I do that all the time. So for instance, if you were trying to play the I'm thinking of game, and you're like, oh, what is that matter? Okay, we could describe it as being either pure or mixture. Does this sound familiar? Okay. And if it's pure, it will be either be an element or a compound. CPD for compound. If it's a mixture, it can be well mixed, that's homogeneous, or it can be chunky, that's heterogeneous. Okay. But if we're thinking, I don't know if you've ever played the 20 questions game, where somebody thinks of something and then you ask them questions, yes or no, and then you try to get at what the matter is. So when you're asking them questions, you're asking them characteristics of that matter they're thinking of. And so you're asking them properties about that matter. So this is just, I don't know, it just totally makes sense. So I'm going to talk about two broad types of properties, and each of the two have a pair. So intensive and extensive properties, they're kind of like yin and yang. Intensive properties, I always think of in as, oh, let me get my thing. In as independent. So independent, not dependent. Independent. Intensive. So if you see it on a test, think independent. Intensive of amount. So in other words, it doesn't matter how much of that matter you have. It's all going to be the same with regard to these properties. So for instance, the color of something. It doesn't matter like if you have 3 pencils or 20 pencils, the color of the pencil is predominantly yellow, okay? So color doesn't change with amount. The reactivity, will it react with water or will it react with air? That doesn't count, that doesn't depend on amount. What temperature it melts or boils at, the boiling point temperature or the melting temperature, I don't care how much, for instance, water you have. If you have a cup of water or if you have a bathtub full of water, that water is going to boil at what, 212 degrees Fahrenheit, okay? It's got that same boiling point temperature regardless of amount. So intensive is independent of amount. So you'd be like, well, aren't most properties independent of amount? And no. So for instance, now we have extensive properties that do depend upon amount. And here's a list of properties about matter, characteristics of matter that do depend upon amount. So for instance, what is the mass of that chunk of matter? Well, it depends upon the amount of the matter that you've set aside to call your chunk of matter, okay? What's the volume of the matter? It does depend upon amount. Moles, this is so fun. If you haven't, the concept of mole, that's just a counted particle. So counted number of particles. How many particles are there? How many water molecules are there? How many moles of water molecules? That depends upon amount. This one, okay, so for instance, paper is combustible. Paper will react. Paper will, if you light it with a match, but how much heat will you get from that paper? So for instance, if I had 1 piece of paper or if I had 10 pieces of paper and I burn them, of course I'm going to get more heat here. Okay, so the amount of heat given off if you burn something is dependent upon amount. So that's intensive and extensive properties. And like I said, I've got one other set of properties coming up